Welcome to Cambridge IGCSE Physics, Lesson 9.1, Centre of Gravity. Today we explore a fundamental concept in physics that explains how objects balance and where their weight appears to act. This is core content for your Cambridge IGCSE Physics 00625 examination. Understanding centre of gravity is essential for many physics applications, from simple balancing acts to complex engineering structures. Let's begin our systematic study of this important topic. Let's examine our learning objectives for today. By the end of this lesson, you will be able to: first, state what is meant by centre of gravity. This means you can provide a clear, accurate definition using proper scientific terminology. Second, understand centre of gravity as a single point. You'll grasp that despite an object's size and shape, its weight acts through one specific location. Third, recognise that weight appears to act from this point. This understanding connects to force diagrams and equilibrium problems. These objectives align with Cambridge IGCSE Assessment Objective 1, focusing on scientific knowledge and vocabulary, and Assessment Objective 2, involving application of concepts. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, centre of gravity, pronounced centre of gravity, means the single point where an object's weight appears to act. This is a theoretical point that may be inside or outside the actual object. Second, weight means the gravitational force acting on an object, measured in newtons, symbol N. Weight always acts downward toward Earth's centre. Third, balance point means the position where an object remains stable without rotating. This connects directly to the centre of gravity concept. Understanding these terms precisely is crucial for Cambridge IGCSE success. Remember, we use SI units throughout, where SI stands for International System of Units. Let's explore our first core concept. What is centre of gravity? The fundamental definition states that centre of gravity is the single point where the entire weight of an object appears to act. This means that no matter how complex an object's shape, we can treat all its weight as acting from one specific location. The key properties are: first, it acts as if all mass is concentrated at one point. This simplifies force calculations enormously. Second, the weight force acts vertically downward through this point, always toward Earth's centre. Third, it determines the object's balance and stability behaviour. Importantly, the centre of gravity may be inside or outside the actual object. The diagram illustrates an irregular object with its centre of gravity marked in red. Notice how the weight vector points straight down from this single point. Now we examine the experimental method for finding centre of gravity. This follows Cambridge IGCSE practical standards. The balancing method involves supporting an object at different points until it balances. The apparatus needed includes a ruler, or irregular object to test, a pivot point such as a pencil or finger, and a stable surface for safety. The method consists of these steps. First, place the pivot under the object at an estimated position. Second, observe if the object tilts or remains level. Third, move the pivot until perfect balance is achieved. Fourth, mark this balance point. The result shows the object balances when the pivot is directly under the centre of gravity. Safety is important. Handle objects carefully to avoid dropping them. The diagram shows a balanced object with the pivot positioned exactly under the centre of gravity, marked by the red dashed line. Let's work through our first example. The problem states a uniform ruler of length 30 centimetres balances at its centre. Where is the centre of gravity? We are given a uniform ruler, meaning mass is evenly distributed, with length equals 30 centimetres, and it balances at its centre. We need to find the position of the centre of gravity. Step 1. Identify the object type. This is a uniform ruler where mass is evenly distributed along its length. Step 2. Apply the principle. For uniform objects, the centre of gravity is located at the geometric centre. Step 3. Calculate the position. 30 centimetres divided by 2 equals 15 centimetres from either end. Step 4. State the answer. The centre of gravity is at the 15 centimetre mark. The key point is that uniform objects always have their centre of gravity at the geometric centre. Example 2 applies the same principle to an irregular shape. The problem is, an irregular cardboard shape balances at point P. What does this tell us about the centre of gravity? Now we analyse step by step. First, identify what happens at the balance point. The weight of the entire object acts through point P. This is the fundamental principle of centre of gravity. Second, apply the definition. Point P must be the centre of gravity because this is where the object balances. Third, understand the stability. The object remains stable when supported at P because the weight acts directly through the support. Fourth, predict behaviour elsewhere. The object would tilt if supported at any other point because the weight would not act through the support. The diagram shows the irregular shape balanced at point P with the weight vector acting straight down through this point. Mathematical skills are crucial for centre of gravity problems. Let's examine 3 key skills. First, uniform objects. For any uniform object, meaning mass is evenly distributed, the centre of gravity equals the geometric centre. For a length L, the centre is at L divided by 2 from either end. This applies to rulers, rods, and regular shapes. Second, combined objects. When objects are joined together, we use the moments principle. The sum of clockwise moments equals the sum of anti-clockwise moments at the balance point. This involves calculating the weighted average position based on masses and distances. Third, stability analysis. An object is stable when its centre of gravity lies above its base of support. It becomes unstable when the centre of gravity moves outside the base of support, causing the object to topple. These skills are essential for Cambridge IGCSE problem solving. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, a uniform rod of length 40 centimetres balances at its centre. Where is the centre of gravity? This tests your understanding of uniform objects and geometric centres. Question 2 is intermediate. It states, an irregular object balances when supported 12 centimetres from one end. What can you conclude? This requires you to apply the balance principle to determine the centre of gravity location. Question 3 is advanced. The question is, explain why a tall object is more likely to topple than a short object. This tests your analytical understanding of stability and centre of gravity height. For all questions, remember to show you're working clearly, include units in measurements, and check your answers make physical sense. Write your answers now before looking at the solutions. Physics principles power our modern world. Let's see how centre of gravity applies in practice. In engineering, architects and structural engineers use centre of gravity principles to design earthquake-resistant buildings. They ensure the centre of gravity remains above the base during ground movement, preventing collapse. In transport, automotive engineers design vehicles with low centres of gravity to prevent rollover accidents. The centre of gravity position affects vehicle stability during cornering and emergency manoeuvres. In sports, gymnasts and divers manipulate their body's centre of gravity to control rotation and maintain balance. Coaches use these principles to improve athletic performance. These applications show why physics matters. Career-wise, physics knowledge leads to structural engineering for building design, automotive engineering for vehicle safety, and sports science for performance optimization. The concepts you learn today become tomorrow's life-saving technologies. Let's review the solutions. For question 1, the answer is 20 centimetres from either end. This is correct because uniform objects have their centre of gravity at the geometric centre. 40 centimetres divided by 2 equals 20 centimetres. For question 2, we conclude the centre of gravity is 12 centimetres from one end. This is where the object balances, which by definition is the centre of gravity location. For question 3, tall objects are more likely to topple because they have higher centres of gravity. When tilted, the centre of gravity moves outside the base of support more easily, causing instability. Now, exam success tips. First, always show you're working. Even if the final answer is wrong, you earn marks for correct method and understanding. Second, include units in every step. Cambridge IGCSE examiners expect proper unit usage throughout. Third, check if your answer is reasonable. If you calculate a centre of gravity outside a small object, reconsider your method. Fourth, read questions carefully. Command words tell you exactly what to do. State means give a definition. Explain means provide reasons. Calculate means find a numerical answer. Let's summarize today's lesson. The key points to remember are: first, the definition. Center of gravity is the single point where an object's entire weight appears to act. This concept simplifies force analysis by treating complex objects as point masses. Second, location. The center of gravity is found at the balance point of any object. This can be determined experimentally by finding where the object balances perfectly. Third, stability. The center of gravity position determines whether objects remain upright or topple over. Objects are stable when the center of gravity lies above the base of support. For further study, review your notes regularly and rewrite definitions in your own words to test understanding. Practice balancing different objects at home to see these principles in action. The next lesson covers moments and equilibrium, which builds directly on today's work by examining how forces and distances combine to create balance. Ensure you understand center of gravity before moving forward, as it's fundamental to equilibrium problems.